All right, so we're going to be solving simple equations, which is mainly one step. There is one that's two in this lesson, but mainly one step. So what you're trying to do is you're trying to get this variable by itself. All right? So I'm going to look at this x, and I'm going to say, okay, what is on this side of the equal sign that I do not want to stay here with the x? And that would be the minus 3. So I have to think about what's opposite of subtracting, which would be adding. So in order to cancel this 3 off on this side, I need to add 3. But to keep this in balance, I also have to add 3 to this side. So when I have negative 3 plus 3, that just gives me 0. So now I have x on this side, then my equal sign. Negative 5 plus 3 is negative 2. And then I'm done. Now I could check myself by saying negative 2 minus 3 is negative 5. So I know that both sides are equal. All right, the same goes for part B. I want this variable by itself. So I don't want anything else on this side of the equal side, the side that has my y. So since I'm adding 2 plus 8 to that y, in order to get rid of it, I would have to subtract 2.8. And if I do that to this side of the equal sign, I also have to do that to this side. So I would subtract 2.8. 2.8 and a negative 2.8, that cancels and just makes 0. And then over here, 0.9 and negative 2.8 would give me, anybody got that? Negative 1.9, correct? All right? Now, we read left to right. We don't read right to left. So in the end, I want your variable to be on the left side and your number to be on the right. So we're just kind of flip-flopping. Now, I could have done that in the beginning. Let's say I wanted to do that in the beginning. Let's say I don't like this on the right side. I could put the y plus 2.8 on the left and the 0.9 on the right. It doesn't matter which is on which side, but when you flip them like that, you don't have to change any of the signs, okay? You just leave it and write this side on the other side and this side on the other side. Okay, now I'm looking over here, and I have a negative out front. So here's the thing. You either have to put that with the top number or the bottom number. It really doesn't matter, but later on, things get easier when you put things with the top. So we're going to put this negative with the n on top. So I'm going to say negative n over 5. That way I don't forget that it's there, and I also don't think it goes with both. Okay? It goes with one or the other. But it can go with the 5 if you wanted it to be on the bottom. Okay? All right, so I'm looking at this n right here, and I see that I have this 5 on the bottom that I don't want to stay here, correct? Because I want the n by itself. So it's n divided by 5. So if I'm dividing by 5, I need to think about what's opposite of dividing, which is multiplying. So I will multiply by 5 on this side and the other side of the equal sign. So if I am multiplying by 5 and I'm dividing by 5, those are going to divide out and make 1 times negative n, which is just negative n. And negative 3 times 5 is negative 15. Now, n is still not by itself. It's being multiplied by a negative 1. So in order to get rid of that, I'm going to have to divide, because the opposite of multiplying is dividing. So I'll divide by a negative 1 on both sides, which gives me 1 times n, which is just n, and then negative 15 divided by negative 1 is positive 15. And if I wanted to check myself, I would just plug 15 in up here. 15 divided by negative 5 is negative 3. So for part B, the variable is x. I want the x by itself. And what is happening to x? It is getting multiplied by pi. So to get rid of pi, I need to divide by pi. Both sides of the equal sign. So if you take pi and divide it by pi, that just makes 1. And same thing over here, right? Pi divided by pi is just 1. So I just get x equals negative 2. Okay, I think I typed C wrong. Okay, so this should be an equal sign. All right, I'm looking at Z, and I see that on this side, Z is being multiplied by 1.3. So to get rid of 1.3, I need to divide by the 1.3. All right, so I cancel, and Z equals 5.2 divided by 1.3, which is 4. All right. All right. So in 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. Someone tell me how you would figure out how fast someone was going with the information that you're given. It's kind of a sciencey question. Distance equals rate times time. So how far did he go? 200 meters. All right. And what would his time be? So 19.32, if my thing would write. And then times, we don't know what the speed was, right? His rate of speed. So now all I have to do is solve for your R, right? By doing what? Dividing. So I'm going to divide by the 19.32. So 200 divided gives you about 10.4. So about 10.4 meters per second. And actually, if you kind of think about it, you really don't have to create an equation for that if you just give it some thought. If you think meters, I should add S there, per second. That means meters goes on top. That's 200, yes. And then the seconds go on bottom. And then, bam, 200 divided by 19.32 gives you meters per second. Okay? Good there? All right, on January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees Fahrenheit at 9 a.m. to negative 4 degrees Fahrenheit at 9:27 a.m. How many degrees did the temperature fall? That is a huge drop. Wow, in 27 minutes. All right, this is legit true. All right, so if we started at 54 and we dropped to -4, how far is that? I'm going to write this, yes, I'm going to write it backwards. If I started at 54, to get to 0, that's 54, correct? And then to get from 0 to -4, that's another 4 degrees. If I take those two together, that makes 58 degrees. That's crazy.